Hi everyone, welcome to another Wolfram Language Design Review. This is going to be a pretty quick one, I hope, I think.
I think so too.
Several live streams today, and this is the first of them. All right, system modeling.
Yeah, so there's only one new function, and this is called system model calibrate, and that basically calibrates parameters in a model with data. That enables you to build what's called a digital twin.
Yeah. Let me ask a general question. I mean, the business about things like making entities for System Modeler, that's not part of this release. Is that correct?
No.
Is that moving along, or is that stalled?
I think it's stalled. We need to reinitiate that.
We really need that. And in the world of LLMs and so on, and that whole flow, I mean, I assume that
so the Wolfram Alpha people need it, is what you mean, right?
Not really. That's no, the point is we can use it. The flow that we have, we are increasingly teaching LLMs to deal with entities in Wolfram language.
Yeah, but this is not a repository of ready-made models. This is a repository of building blocks from which you can build models.
I understand that, but I mean, like to give you an example, we had an example from Nick yesterday or something about the quantum framework, okay, where so Christopher built this thing that is a way of making custom endpoints for LLMs, okay? So this was, I think, done using an endpoint specifically that knows about our quantum framework, okay? And you could describe a quantum circuit in natural language, and it would make you a quantum circuit and then be able to compute from it. And I have to believe we can do the same thing for system modeling.
Yeah.
Right?
Yeah, you probably could. I mean, because if you can build a programming language that does it, you can certainly describe it in text. And
you can describe it roughly in text.
So
right, you can describe it roughly, and it will give you starting points, which is, I think, what is really useful. And then you tweak it up using, potentially using System Modeler or using code. Does that make sense?
Yeah.
I think it's really an important thing. And I think that the enabling glue, if we had entities, we could just do it immediately. Because we already have.
I don't think so, but we'll take another crack at it.
I mean, this is what we had hoped to do right when we started working with System Modeler, was to get a flow from Wolfram Alpha through System Modeler. This is now a much richer way of handling natural language descriptions. Anyway, let's come to what we have to do specifically now. Boy, this is complicated. Wow. Ooh, we don't usually do that, of having lowercase first letters in names like this.
No.
We usually tend to uppercase them.
Yeah.
Okay, we can change it. Yep.
All right. So let's see the example. Wow. Why is this? Okay, so here we've got a model. And here we've got, oh, I wish you wouldn't do this of putting these multiple things in one cell. Please don't do that.
All right, I fixed that. Yeah.
I think. I mean, unless it breaks how our example thing works.
No, it doesn't.
Okay.
You're usually the one that wants it in one cell, just because copy to click is easier. But
well, okay, fair enough. But maybe it should be in one cell.
I'm not very keen on it either. I don't particularly like multiple things in a cell.
Okay. All right. So what are the two numbers here for inertia? What does inertia 2 mean?
It's the modeler of this example used that to call one of the parameters in the model.
Yeah, I understand, but that parameter is a 2-vector or something. Or is
It's inertia in
No.
this case. That's the variable that we are trying to fit, and the parameters
I think
are.
I'm guessing. I don't know the details of this model, but I'm guessing there is an inertia 1 and an inertia 2.
Okay, but then the first element
Looking at
here
the
is the
picture
time. Is that correct?
Yes.
Okay. Is that obvious from this? I mean, is time always a parameter in these things, or could it be something different? I mean, could it be?
No, so the system models always simulate things over time. The parameters are parameters, so they don't vary with time, in which we don't call them parameters when they vary with time.
Okay, but inertia 2 is a non-variable parameter. Is that true?
Right.
That's a variable. That's a variable that changes in time. And
Oh, so you're answering different things there. So this is a variable, not a parameter in the definition.
yes, and the other ones are the parameters.
Oh, yes.
Sorry. Okay. So this is a variable, and it appears. So what are you trying to compute here? What is the difference between this model and this model?
The output model has calibrated parameters. They are consistent with the data. So when you build models, okay, it's like if you need to use a resistor, there is a parameter called resistance, but it has a default value. All the components in system model has a default value, and
Okay.
I don't.
So how would I look at this thing with how would I look at the parameter values? Did I say parameters or something?
Yes, you can ask for parameter values, but first you need to load this.
What?
Yes, you can ask for parameter values, but first you need to load the system modeling functionality.
Why? What do you mean I have to load it?
Yeah, so the symbol
where does it what do you mean I have to load it?
The symbol on its own doesn't
I have
load.
to do this, something like this.
Yes, yeah.
That's a
Why
total
wouldn't
hack.
that do it on its own?
We haven't fixed that. Yeah, it's
Well, fix it.
Yeah.
Okay. The other thing that you haven't fixed is this needs to have an autocomplete. If I give that picture, right? See that? And I start typing here, that should give an autocomplete menu.
Right, I looked into that. Yeah.
Why is this taking forever? Okay. All right. So this has inertia dot. I don't see an inertia 2.
Because these are the parameters.
I misspoke, Stephen. So variables are the things over time. Parameters are the things.
Do I say variables?
System variables.
Okay. All right. So now, in what sense is this so? So then you're calibrating resistor 1.R and damper, spring damper 1, whatever. I mean, it would be nice, wouldn't it, to have some indication in the icon, like for a neural net. If I just say, if I say something like, net model of Lynette.
Well, you can open it up. And system modeler
okay.
has all that full drill down.
Okay, well, let's look at that. Okay, so I mean, because what this shows is that's an uninitialized neural net, which is essentially
but it's still initialized. It's not uninitialized. It is initialized. It's just wrong values.
Modeler. Yeah.
So people build what we do physical model building, but they may not know how those parameters that they use, they might even use symbolic parameters, relate to the real world parameters.
Okay, but this again doesn't really have that information, right?
No, I thought it would show, the components, the diagram, as opposed to the icon. but their icon diagram was the same thing. So there was nothing more.
Right. I guess you get the tooltips over the components, but that's a little bit of information.
Yeah, but they don't give the values. I mean, whatever
Right.
it was that you were setting.
Well, system modeler is the tool for that we sell.
Yeah, okay. For doing what? For determining all those parameter values.
I mean, if you want a GUI where you can drill down and know the exact structure, where you can build it with a GUI,
modeler.
that is the tool for that.
Right.
It's
okay.
not
So
Mathematica.
I'm just trying to understand in the obscurity of the fact that I have an input here, I have this thing here, and I appear to get the same thing back.
No, well, that's the default thing. It's kind of like many things where we have many of the things that we can, return. So you can the spec up there, you can tell you can get other things like quality measures. You'll see that often you want, for instance, confidence bands. How is this fitted model reproducing the data?
Right. But so here, the default is model to model.
Yeah.
So the default is that we create a copy.
Excuse me, why is this blank?
What was blank? I mean, there was a progress monitor.
It did nothing. It was doing nothing.
Okay, can you try again? I think that's bug.
I can't interrupt. Okay. Should I just try it again?
Yep.
Why was it pink at the beginning?
Yeah, there was something
there. Yeah, I can look into that as well. So the default is that we make a copy of the model with the new parameters. So
it's like getting a formula out.
Yeah. Why is it conniptioning? Why is it kind of? You can make it. You see what it's doing. It's got the little pulsification there, which happens when the number first comes over. You need plot range padding to prevent it from having that little conniption when the number first comes into range. Do you see what I'm talking about?
Okay, like an adaptive range plot.
No.
Plot range.
No, the frame should not move. Right? Do you see what I'm saying? The frame should not move.
All right.
Right? As it was wiggling around. The frame was wiggling around. If you ask the machine learning people, they have a solution to that.
Okay.
Okay. And this picture should look really like the machine learning picture. Am I making sense?
All right. Yeah.
I think these fonts are a bit big. I think, if you're setting more stuff. Okay. Did you see what I'm saying? That it wiggles every time? Did you see that? Do you see what it's doing?
All right. Okay.
Do you see what it's doing?
Yes.
Yeah. Okay. So it shouldn't do that. And it's doing that because it's leaving more space when a number first comes in and sticks out of the end.
I see.
You see what I'm saying? So that can be fixed with plot range padding. And that steps had some kind of backtick after it, I believe. Just details, but we go right.
Okay.
So if you scroll down, Stephen, to the next example there, see that here's a different output. There you can see that you get a confidence bands.
Yeah. As a function of what? As a function of time.
Yeah. I think that's the money shot. I think that's the most important thing people want. But there's, as you could see up there, there's a ton of other things that you can get.
Okay, so calibrated system model. So let me do that for this case. So that is saying instead of these, right?
Not at the end. So because that's like a property. So after the parameters,
I can't get it from the model itself. I can only get it from the calibration process. Is that correct?
Yes.
Right.
But this gets you an object where you can get everything.
Why is this auto completing wrong?
Because it usually needs the documentation build before it can derive the auto completions.
Okay. So this is, why does it have to? Okay, let's take a look. Why is this, I mean, the loss, what is it now doing? it's not showing an increasing range there. Why is it? I don't understand. The steps, why is it still running? Do you understand what I'm asking?
Yes, I think it's just
So when
I don't think it's
okay, it crashed. Brilliant. It crashed the kernel.
That's what it was busy doing.
It's not great. Okay, all right, let's take a look some more at your thing. Model predictive controller.
There's no design change. It's just faster and better algorithms.
Okay. Obviously, we need to know why it crashed here.
Obviously.
Okay, and then, I mean, this thing, gosh, has a million options, which I'm never going to understand.
No, those are properties.
Right.
There's a million properties. There's very few options. And we probably will, but that's part of another discussion we should have, kind of introduce subsections in notes so you can have options and properties in separate.
I think we should do that. I think it's time.
Isn't that nice?
Yeah, it is nice. But let me understand what it is. So as a function of time, that's showing the data, and then it's showing. Okay, so those are values of inertia 2 as a function of time. And then this is showing what the model is doing, but I don't understand what the bands are doing.
Those are uncertainty for a function of time. It's like if you had an around function.
But the parameters, I don't understand. In the end, this thing fitted certain parameters, yes or no?
Yeah. And so, so there's some uncertainty in those parameters. Now, what happened to the result when you solve those differential equations, when you have uncertainty in some of the parameters that goes in? That's going to lead to a whole slew of different solution trajectories coming out, right?
I see. So this is the envelope of all those solution trajectories.
Exactly. Yes.
But is it all up to some confidence level?
Confidence level. I mean, it's interesting to do all too. That's a different kind of problem, which is
I get it. It's nice. It's very nice. I still want to use this stuff for something myself. How similar is this in the end to the machine learning framework? With validation sets and so on.
I mean, the machine learning framework is similar to the regression framework, right? Because it sort of is, right? Yeah. And this is similar to both of those because it sort of is. But what's different here, which we haven't tackled before, is that you're minimizing an integral where you have differential equation constraints.
Yes.
In the other cases, we minimize the sum with algebraic constraints, typically.
Right.
If machine learning usually doesn't even have constraints, right? They just, I think machine learning doesn't typically have constraints.
No, it doesn't.
It's unconstrained.
It has some. I mean, it tries to use things like normalization layers to not have things blow up. It's a different approach.
Right. And so this is an example of dynamic optimization, or sort of another level of optimization, if you like, to do this.
Right. But so for example, the use of the term loss here, has that always been used in control theory, or is that new to post machine learning?
No, it's been used.
So machine learning got that from control systems.
Well, yeah, this is part of it.
It's not what you say in statistics.
Yeah, but they're kind of all the same thing. So this part of, if you like, control is, does have a name. It's called system identification, and it's a big kind of field in its own right. But that field itself basically picked, almost everything up from statistics.
Indeed. But like the term loss,
yeah,
I had not really heard that term except in machine learning.
Oh, yeah, no. So I was in a group where we were sort of world experts on system identification, and we used loss since apparently.
Okay, but that's not the term in statistics. In statistics, it will be residual or something like that, wouldn't it?
No, I mean, you use loss function there too. Because you vary the loss function.
Okay.
And it's the same guy, Stephen. Like Trevor Hasty was a statistics guy that became, the machine learning guy.
Yeah. Well, I mean, I understand it's one of these, it's all the same thing in the end.
Right.
So can we in fact use this? Here's a question. How does this relate to like our reinforcement learning efforts and things?
That's a little, it's a little bit a different angle, which we want to tackle as well. I think that there are two kinds of things that we can do with respect to reinforcement learning. So for reinforcement learning, we need an environment where you can learn from.
Sure. But you have one in system model because you have the actual.
Exactly. So I think that is a use case. Okay. Right. So we need to package it up so that one can take those things and kind of learn from.
Right. But what you've got here is your model here is differential equations.
Yeah.
In typical machine learning nowadays, the model is a bunch of neural nets or a neural net.
Yeah.
And so in principle, you could have a version of this, calibrated, whatever it is, where
we could do also in a way, I mean, interestingly, we could, for this very function here, in principle, I could do I could fit differential equations to differential equations. Okay. So if I have, instead of finite measurement data, maybe I have a really high fidelity physical model.
Yep.
And now I want to calibrate a much simpler physical model, but I want to get the best one, the one that approximates it the best in this sense that I defined, the loss sense.
Yeah, right. Well, okay, but I mean, guess what I'm asking is there a way with our frameworks to say, instead of there being a differential equation inside of the system model, there's actually a neural net inside of the system model, and system model calibrate would basically train the neural net instead of setting parameters for the ODE.
No, but formally you can include a neural net in system models. We added ONNX support. So if you can represent your neural net as an ONNX neural net, then it can be part of a system model.
Which we can supposedly export to, but I mean,
exactly,
a bit of a floppy format. So,
right.
Okay. All right. Well, looks good. I mean, I think it will be really worthwhile to understand this plumbing, given that we have a, well-developed neural net machine learning.
No. I mean, we are aware and we are talking to each other repeatedly. And so, but this is an important use case that this addresses, as you can imagine.
Yep.
Here's another cool thing, which I'm sure that you thought of, but you're going to call it something else, and I'd be keen to hear what you call it.
Yeah.
Okay. So let's say that I'm observing a system. I'm taking measurements from some of its variables. Okay. And I run the system calibrate that will, estimate and correctly calibrate some of the parameters.
Mm-hmm.
Maybe what I really wanted to find out was the parameter, because that is it's something internal to the model, like viscosity inside of the system that I couldn't measure.
Sure.
Okay. So this is a way to build a sensor. In fact, many sensors work this way, that you compute your way to.
Yeah, I mean, so whatever they're called, virtual. What are they called? Even virtual sensors? What are they called? There's a name for that.
Yeah. Yes. What are
synthetic sensors or something.
Synthetic sensors, I think they're called. Yeah. And so that might be
That is
itself
interesting.
something interesting, right?
That is interesting. That's quite interesting. And it's, yeah, that's quite interesting. All right, well, cool stuff. Okay, I don't think there's any more we need to go over with this right now.
That was it. Yep.
Okay, Roger, I'll see you in another half an hour or something at another design review.
Okay.
Okay, thanks, system model control systems folk.
Thank you.
Good work. Okay,
Bye.
see you. Bye.